Hello everyone, now we will learn how to connect our HPC, high performance computing node server to run a local LLM, large language model. So let's get started. This is our SSH connection that you obtained once you registered to NAISS. So this is the password and username that you will use to SSH to our HPC server. Now we will develop one script to run an LLM on our GPU cluster. So as we are running on an HPC server, we start with bin-bash-l. This is the pretty common starting. Second, we will use sbatch to run our slurm scripts. So sbatch, now we will configure our sbatch. This is our project number. So in that way we will authenticate to server, so it will count to our consumption. Second, our servers is Alvis. We have GPUs on Alvis server. Then we will configure our GPUs. We will select 4 A40 NVIDIA GPU. 4 is important here. If we select 4, we can run around 100 billion parameter LLMs. Then this is our number of nodes. Please note that a node contains multiple GPUs. Here we are selecting only 4 GPUs on one node. Okay? What is golden information here? If we select one node, then the GPUs that we are using means that shared. While we are using this GPU, someone else also uses. But once you select more than one, if we select 2 nodes, A42, then this 2 GPU is dedicated to our work. Now we are selecting the time, how long this process is going to run. This is seconds, minutes, hours. So for 5 hours this script is going to run, and this is the dates. If we want to set a date, for example 3 days, we will, or 5 days, we will set this. What is important here? Pretty much all HPCs, there is a system known as Watchdog. What does this mean? Once we run a script, it fires up a GPU and loads our model there, right? This watchdog inspects our operations there. So it tracks our utilization. If you run an LLM but you are not using, it will automatically shut down. You may think that we are not overloading GPUs, why it is shutting down? So the logic is different. I don't want to get into it. If you run a script, you should be using the resources that you allocated. Otherwise, it's gonna shut down. Okay, this is our template script where you will find this script in our shared storage. In our HPC, we have GPUs we can allocate, but we have also a dedicated storage. This year we have 1.5 terabytes of storage. So I will keep this template there, then you can copy and edit for yourself. Cool. Now I'm going to clean up my screen and clean up the modules here. Then, as we are working with large language models, we need to download it, right? And where we download it, open source models, Hugging Face. That's why you need to put your Hugging Face token here. I'm not going to write it. I don't want to show it to you. That's why I keep it empty. Plus, in Mimer, the shared storage on NAISS already contains open source LLMs. Why? Otherwise, everyone will need to download these models, right? Instead of everyone is required to download such models, administrators already handles this. And we can find mainstream models in Mimer shared storage, so we can use those. So For example, if you would like to run a model which is very common but you cannot find on the storage, or there is a newer model, we can ask NAISS Alvis to update it. So currently what we have on Mimer, OpenAI, GPT-OS 20 billion, 120 billion, LLama, QN, Gamma is a gated model. That's why we cannot find it. Please look for Google what is gated. We can find ungated models absolutely on Hugging Face, but I don't know why Alvis administrators does not download such models. But DeepSeek, yes, now we can find DeepSeek on Hugging Face. And this is the environment variable, our vLLM script, I'm going to talk about it, looks our environment variables to access LLM files. HF model is set to Mimer, no backup, datasets, LLM, Hugging Face, hub models. Okay. Normally, in normal life, once you use your own computer, not an HPC, you set your HF model directory to Hugging Face hub. But here in HPCs, we are not doing this. We are setting full path. Let me read together. Models, OpenAI, GPT-OS, 20 billion, snapshots, and a hash value. OpenAI GPT-OS 20 billion may have multiple versions. One of them released early 2025, one of them released late 2025, so there are two versions. And Alvis administrators downloaded these two models, and these are called as snapshots. Different snapshots. That's why we are giving full path. But in normal life, we only give this hub and write our base model, another environment variable. I want to use GPT-OS 120 billion. That's all. Or we write like that, OpenAI / GPT-OS 20 billion. So while our vLLM tool finds these two variables, HF model and base model, it merges. I understand there is no slash here, but it automatically converts to that format because this naming convention is standard. And our tools, for example, vLLM or Llama and similar tools can find this path. In HPC, this convention is different. That's why I want to highlight this. Then HF home, Mimer, no backup, datasets, LLM, Hugging Face, hub. This is the home directory. And our vLLM first will go to here. But as we are using HPC, we need to write the full path. Otherwise, we would use this naming convention. If you are using your own computer, you will use OpenAI GPT-OS 120B as the HF model value. Then we need to provide Apptainer image. This is something like VirtualBox, VMware. Apptainer comes from application container. It produces vLLM.cif file. It's usually around 8 gigabytes as far as I remember. This is a very old version. We never use this. I guess now we need to create our CIF model by using this version. Here we would like our Apptainer to set vLLM CIF to our environment variable. You don't need to generate this file because it is already generated and it is already in our shared location. As you see, Mimer, no backup, groups, LLM security research, our shared location. And I created a folder there, vLLM CIF, our Apptainer located here. How I created it, we will see. And this is the API port. I selected this number to run our LLM models. Then vLLM options. So this is the tool that fires up our LLM. vLLM serve is the command which serves HF model. HF model is here. This is our exact path of our model. Then we set our port. These are some variables which configures our LLM. I'm not gonna get into it. And this is the third model name. I put it Royal Hacking Lab Dr. Emre Süren to help me see which is my model. Then you see here how I built the CIF image. So once you run this script, it first checks if we have a CIF, vLLM CIF. Otherwise, it creates Apptainer build CIF image. This is our location. Then this is how we can create. As you see, 13 is our version and previous models are old. If you run with the old models, your newest models will not run because all dependencies, Python libraries are managed with this Apptainer. That's why we keep it 13. This is the latest version. You can find all applications in app directory on Mimer. I created one directory, vLLM, then starting the server with the options here, vLLM options, Apptainer exec, the location of our CIF image. We are running our CIF image with these options. If there is an error, we redirect it here. Otherwise, this is the output from our execution. This is quite important once you are running a script, any batch job. I strongly suggest you to also track the outputs here, vLLM out, and you will see these echo statements and you will see where it hangs or if it runs correctly. Once this big script fails, you should be able to gracefully close all resources. This line is for it. And now we are loading LLM with Apptainer exec to the memory. Once it is loaded, and an HTTP service will run, and we will be able to access our model through an API. Here, this is the local IP. I'm testing with this script if our model loaded or not. As I don't know the IP address, what IP address it's gonna assign, that's why I'm using local IP. But once this is executed, we will see at what IP address running. Okay, here I'm just testing. One of the golden information here, after running Apptainer exec statement, we are waiting around 10 minutes here to try running an HTTP server. Why? Because it takes time to load this image to the memory. If we don't wait here and directly try to run, it will never run. For example, you keep it here 2 minutes and run 120 billion model. It will never reach that point and you will never be able to run your server. That's why this is quite important. We are waiting around 10 minutes. My current experience with HPC, we have with 10 minutes, pretty much we can run any model. Then we will see our log as application startup complete in our vLLM out file. Then we will see the IP address. Actually, Alvis assigns us a domain address here, but you can just ping to the domain address to learn the IP address. Why this is important? You don't want to install your application to Alvis because you are running this application on your computer. You just need LLM access. Then you can do reverse tunneling to access this model. I will tell you about how we can reverse tunnel to Alvis servers so we can access from our computer. Absolutely, our computer should be connected to SUNET. As you are at KTH or your university, you are getting edu-rom IP address, so you can access through reverse tunnel. Otherwise, if you are at home, you first need to connect through VPN to SUNET, get an IP address, then you will run your reverse tunnel. From this reverse tunnel, you will connect your computer to Alvis, then you will run your application on your computer, which will connect to the LLM on the Alvis. Now let's try this script to run. sbatch job script, here template, SLURM. So we will run like that, template, SLURM. We can run it. Then we will use our username to query the status of our script. First, it will wait in the queue, right? Then it will be running. Once you are done with your job, then you will say scancel job ID. How you can learn your job ID? With squeue user, your username. Super good. Now let's get back to our shell ls cd desktop Mimer LLM security research. This is our shared repository. This is our project name. Then ls. So these are the files we have in our repository. I have created one shortcut to Mimer models. You can see Mimer models. Here we have these models on our Mimer server: Qwen, OpenAI, Llama, Gemma. Probably this Gemma is ungated model. That's why we have here. Gated model means that you need to go to Hugging Face and request an access. Once they approve, then you can use it. So models are doing this to track usage. That's why we need it. Then this is our model directory. Template slurm. This is our script. vLLM, LL, vLLM. This is our directory. As you can see, our Apptainer is here. This is our output, our error message. Once we run our command, our script, also in the same directory with the script, there is another additional output file is created where we can see everything: error messages, output files, and many more things. And we have LL models. I created one directory here, local models, HF cache. So these are the models that we downloaded ourselves. Those are old models. We will delete soon. Then we will have some models here like Gemma, gated version. If you can't find the model that you want, you can download it here. As you know, we have 1.5 terabytes of storage. You can use our server, but please put it under local models. Mimer models, I showed you. This is local models. This is groups where you can find our project. This is data sets. During our research, if we create a data set, absolutely we will put it there. This is my other project, CTI, Cyber Threat Intelligence. I created a standalone directory for it. Then we will create one for vulnerability research here. But now let's keep it simple. I would like to run my script now. Clear sbatch template, right? If you want to see the content of it, is the same content. So now I'm gonna run it. Clear sbatch template, right? S-U. This is my username. Now we see the status. This is the job ID. We will use it to stop our process, cancel the process. And this is our partition. We have our GPU on Alvis. And this is the name of our script template. And never use template name. Okay, I will track this usage, and it's easy for me to understand whose script is running. Please use your name. I can identify who run it, by the way. This is my username. This is pending, 0 seconds. Priority is 1. I will run it again to see if, yes, now it is running. But what I told you, once we run this command, and we will have a slurm out file. As you can see, this is our process ID, also job ID. Now let's the content of our out file. This is our echo messages, checking for CIF image, then starting server with. This is starting the vLLM server. As we have seen, vLLM serve, and this is the model. This is our port number. These are the configurations of GPU. And finally, this is the name of our vLLM, waiting for server startup. We are waiting LLM server to start up, then it will fire up our HTTP server, then we will access. Yes, this is our model here. Copy. Then I will click Ctrl C. How we can access our endpoint? Let's say curl. It says not found. Usually under V1 models, right? Yes. Here is the object list data Royal Hacking Lab, Dr. Emre Süren model, created, owned by vLLM, root, whatever. So we can use curl to access. Now I will ping to this domain to see the IP address. Anyway, I don't want to ping right now, but once you ping, you will see the IP address there. So I guess we are done. Then I want to show you how we can cancel it, right? Cancel, and this is the job ID. Paste. Then query our, yes, it's going to purge. That's all.